Welcome back, everyone. Go ahead and open your books to page 291. We're going to be starting in lesson 19.2, talking about negative and zero powers. So we need to understand what is meant by negative and zero powers, and then continue to simplify expressions involving exponents. And make sure you have your exponent graphic organizer with you. We're going to add to that today as well. So write each quotient in expanded form and simplify it. Then we're going to apply the quotient of powers property. And the first one, the table has been done for us. So if we look, we have 2 to the 5th power divided by 2 to the 8th power. Now, 2 to the 5th power is 2 multiplied by itself 5 times, and 2 multiplied by itself 8 times. Then remember that these cancel out because 2 divided by 2 is 1. So I'm going to put 1 in my numerator as a placeholder. And in the denominator, we have 2 times 2 times 2, which is 2 to the 3rd power, or 2 cubed left over. Now, when I have a division problem, what do we do with the exponents? We subtract. So if I think about 5 minus 8, I get 2 to the negative 3rd power. But that looks different than this answer. So let's keep going, and we're going to see what is happening here and see if we can come up with a pattern. So we have 5 cubed. So 5 times 5 times 5. And then we have 5 to the 6th power. And then I'm going to take these and cancel them out. That's 1, 1, and 1. So I'm going to put a 1 in my numerator as a placeholder, and in the denominator I have 5 cubed. But if I think about subtracting my exponents, it's 5. What's 3 minus 6? We get a negative 3. Okay. So go ahead and keep going. Do the A's. Cancel them out. So I have 1 over a to the 5th power. And then if I remember my rule, when I'm dividing, I subtract the exponents. 3 minus 8 is negative 5. And then let's do the x's. So I have 1 over x to the 6th power. And 4 minus 10 is negative 6. So we need to talk about what is happening from here to here. From here to here. So what do you think I would put in this little box? If I have 1 over a to the n, and I pull that out and it equals a to the something. So look, I have 1 over a to the 5th power, and that equals, what does that equal? A to the negative 5th power? So 1 over x to the 6th equals x to the negative 6th power. So this needs to be a negative n. So let's go to our graphic organizer where we see the negative power. And let's start filling this box in. A negative exponent becomes a reciprocal with a positive exponent. So if you remember when we were looking at perpendicular lines, we were talking about reciprocals. That just means that you flip the fraction. So negative exponents are reciprocals. So let me show you what that looks like. There's two different ways we can write this. So let's do what the book had, which was 1 over a to the negative n, and that equals, I'm going to flip the fraction and make it positive. So I'm going to make it a to the n, and then we could put it over 1, but we know that all whole numbers are being divided by 1, and we never really write that. Okay, so just bring it up to the top and make it a positive exponent. Okay, or if I start with a negative exponent, then I need to flip it, move it to the bottom of your fraction, and make it a positive. So negative exponents are not allowed. We cannot have negatives. So we have to move them and make them positive. So if it's in the numerator, we move it to the denominator and make it positive. If it's negative in the denominator, we move it to the numerator and we make it positive. Okay, so let's do some examples here. If I have 5 to the negative 2nd power, I cannot have a negative, and it's currently in the numerator, it's in the top, so I need to move it to the bottom and make it positive. Okay, or let's do another example. If I have 8y squared x to the negative 3rd power, I cannot have the negative exponent, so I need to take this and I need to move it to the bottom and make a fraction. So it would be 8y squared over x to the positive 3rd power, x cubed. I leave the 8y squared in the numerator because it's happy up there. They're positive up there, so leave them. And let's do one more example. I have 5x to the negative 4th power z negative 2. So what is 5 divided by 10? Let's do that first. We get 1/2 or 1 over 2. And then these exponents cannot be negative. So think about this being unhappy and it's living upstairs. We want to move it downstairs and make it happy. This is unhappy and it's living downstairs. We're going to move it upstairs and make it happy. Turn them positive. Okay, so in the numerator now, upstairs, we have z squared, make it positive. And then the denominator, we have x to the 4th power, make it a positive. So we just have to move them around. So negative exponents are a big no-no. We cannot have them, so we always have to get rid of them. And I always clean them up at the end. Okay, I do all the other work first, and then at the very end, I get rid of the negatives. All right, back in our book, question 3. Again, we have another table. Okay, and it looks like it's another quotient problem, fraction, division. So I have 2 to the 4th power over 2 to the 4th power. So when we expand those out, it's 2 times 2 times 2 times 2. And then these all cancel, 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 cancel. And anytime we're doing 2 divided by 2, it's just 1. So we're left with 1. But you know that if we have a division problem, we are subtracting our exponents. So keep the base, 2 to the 4th power minus 4. So 4 minus 4 is 0. Okay, so same thing, let's do it with the 5s. So 5 divided by 5 is 1. All of these become 1. 1 times 1 times 1 times 1 is just 1. But think about keeping the base, which is 5, and 6 minus 6 is 0. These all cancel, so it equals 1, but 3 minus 3 is 0. So this is equal to this, so 2 to the 0 power equals 1. 5 to the 0 power equals 1. A to the 0 power equals 1. So x to the 0 power, b to the 0 power, 582 to the 0 power, anything to the 0 power is 1. Banana to the 0 power is 1. Okay, so we're going to write this in our organizer as well. Anything to the 0 power is 1. Always 1. Always, always, always. So a to the 0 power equals 1. So if I give you a decimal, 2.75 to the 0 power, it equals 1. Okay. If I have parentheses, this whole thing inside my parentheses, a squared b cubed c, is being raised to the 0 power, so that equals 1. Let's look at this example. Is 5 being raised to the 0 power? No, there would be a 1 there. Is x being raised to the 0 power? No, there would be a little 1 there. The only thing that's raised to the 0 power is the y. So this right here becomes a 1. So it's like 5x times 1 basically. So we're left with the 5x. Okay? All right, let's take a look at question 5. Use the properties of exponents to evaluate the following expressions. So I want you to use all of the rules that we have learned so far with your organizer out in front of you, and I want you to answer questions A through D. Go ahead and pause the video and work on these questions. Letter A, I cannot have a negative exponent, so I need to move it to the denominator and make it positive. Okay, or you can think about this being over 1 and we kind of have to flip the fraction, right? Or think about moving this to the denominator, and when I move it to the denominator, I need a placeholder in my numerator, so that placeholder is 1. And when I move it to the denominator, it becomes happy, and so it's a positive 3. Now, there are multiple ways to do letter B. When I see a division problem, I know that I keep my base, which is 10, and I subtract the exponents. So 2 minus negative 2. 2 minus negative 2 is 2 plus 2, right? 2 negatives make a positive, and 2 plus 2 is 4. Now remember, I'm okay with you leaving this as 10 to the 4th power. If you want, you can type that into your calculator and get the answer, or you can leave it as 10 to the 4th. So when I look at question B, I do the property first, and then I clean up my negatives last. Okay, so I did the subtraction portion of the question first, and then I would clean up at the very end. Right? Some of you might have taken this negative exponent and moved it up to the top. And so you had 10 squared times 10 squared when you moved it up. You keep the base, and we add the exponents for a multiplication question, and we still get the same answer. So you can think about it either way. I do the question and clean up my negatives at the very end. Just like when I'm cooking. Cook the cake first, or the meal, and at the very end, I clean up. Okay, letter C. This becomes a 1, so I don't really have to do anything with it or think about it. And I cannot have 3 to the negative 2nd power, so I have to clean that up. So what I'm going to do is move this to the bottom of my fraction, so I got to put a 1 on top, 3 to the positive 2. And you can leave your answer like that, or if you wanted to, you could say 3 squared is 9. Either answer is acceptable. Letter D, anything to the 0 power is 1. All right. Let's walk through example A. No, let's not go through this example. Because the book does it kind of funny and it's already worked out for you. Let's go to the bottom of this same page, 292, and let's do the try these A. You have 3 of them, A, B, C. So go ahead and pause the video, and I want you to try to do these questions. So remember, for a multiplication problem, we're going to do 2 times 5, and we get 10. Okay, then my next base that I see is a squared times a. When we're multiplying, remember we keep the base, add the exponent. So 2 plus 1 is 3. And then I'm going to look at the b. So I have negative 3 plus 1, which is negative 2. Now I'm going to clean it up, which means I need to take this negative exponent and move it to the basement and make it happy. So it's going to be 10a cubed divided by b squared, and this would be my final answer. Question B. 10 divided by 5 is 2. And then I have x squared minus a negative 3. 2 negatives make a positive. So this becomes 2 plus 3. So it's x to the 5th power. Then if you're looking at your y's, you have negative 4 minus a negative 1. 2 negatives make a positive. So it's negative 4 plus 1, which is negative 3. But this negative is unhappy, so I need to take it and move it. So my final answer is 2x to the 5th power over y cubed. And letter C, anything to the 0 power is 1. So that just simplifies to a 1. All right, go ahead and try questions 6 through 11. You can do it. This becomes 1 over z cubed. This is 1, and 12 times 1 is just 12. Then I have negative 4 minus a negative 2, so this becomes negative 4 plus 2, so that's negative 2, but I can't have a negative exponent, so I need to turn it into a fraction and make it positive. When we're multiplying for number 9, keep the base, so that's 2, and add the exponent. 3 plus negative 6, so 3 minus 6 is negative 3. Nope, but I gotta turn it into a fraction and make it positive. Okay, I need to leave this 4 alone because there's no other number that I can divide it with. Put the x, and it's negative 2 minus 3, so that's negative 5. And then this needs to move to the denominator. And it becomes positive. The last question, number 11, the negative 5 is okay because it's just a negative number. It does not have a negative exponent, so leave it. And this becomes 1, so it's like negative 5 divided by 1, which is just negative 5.